So did you have a nice little break? How did those problems with mean, median, and mode work out for you? Remember, if you have questions, shoot me an email or show up for the Zoom class. But let me know. We can meet together to go over things. I can also look at particular problems. So there's the in the online homework, there's that option to ask the instructor. It sends me a copy of the question. I can help out with those. Okay, so let's look at measures of dispersion. So how spread out are things? Again, finding the middle of the data, that's important. The mean, the average, what does the average look like? But as important to understand what a data set really looks like is how spread out is the data. Is it skewed to one side or the other? Are there more of this than that? Just how spread out are things? Because you could have the same median. I earlier referred to how teaching at a community college, I see some students as young as 12 years old and some students as old as 80 years old. Well, that might give an average age in the 40s, or there could be one of each, and then most of the people are in their early 20s, so that would give us, a little. But we could have exactly the same median or the same mean, but we could have a classroom where everyone was 12 or 80. There was 5 12-year-olds and 5 80-year-olds, but that's a different classroom than if there was one of each, and then everyone else, say, was 19 years old. Different dispersions, and that's what this section is going to help us see, is that the mean and the median by themselves only give a portion of the story of the data. We need to know how spread out it is as well. So we will be able to look at the data, the range, and we'll be able to do standard deviation. Now, typically, range is what we'll use if we're also measuring with the median, and you'll see the calculation, or we also have the 5-number summary and stuff, but range is, we can use it with the standard deviation, but typically we'll go with the median. Standard deviation, though, is a calculation that is similarly done as the mean. You would not, if you're using the median to measure the middle, you would not use the standard deviation. The only time we use standard deviation is if we're referring to the mean. So that's kind of when you see someone talk about standard deviation, you go, oh, you're using the mean to figure out the middle. And notice the mode's not even in here. Okay, so the range is just, again, like what we did last time. It gives us a quick look at maybe a large data group, take the largest and the smallest, subtract them, and then we can see sort of how much spread there is between the top and the bottom. So things like temperatures, oftentimes we'll use the temperature range from maybe the cold in the evening to the hot in the afternoon. So hottest day is 89 and the coldest day is 61. Again, these are both daytime temperatures. So it could say on Honolulu, there's a 28-degree range spread of the data of the temperature, depending upon. I'd assume the 61 is probably in the wintertime, and then the hottest day, 89 for us in Arizona. That's not hot at all, but it's you have humidity down there because of all the water around it. Okay, but that's one way, is to look at range, which is just simply a calculation. Take the highest value and subtract the lowest value. What's left is the range, and that's kind of how spread out it is from high to low. In Phoenix area, what we get up in the 120s oftentimes, and our low, I don't know, over the winter, we're like 34. I don't, maybe 40. I could do 40 to make it an easier calculation, but that's 20, 60, 70, 80, 86 degree range. Wow, that's a big swing. It's almost, our range is almost more than their high temperature. So this is for Phoenix. and I'm just guessing. I don't have the data, but I lived through summer here before, and so I'm sure you have too. You know, there's 120 degrees, and there's actually I think our absolute high is maybe 122, maybe 123. We're close. I might be off on this last winter whether we got down to 34 or not. I'm sure at night we did. Since they're taking basically the daytime highs. I don't know that we'll figure it out, but you see the calculation. Okay, so computing the range again, take the high minus the low. So here we go. What is this? Age of oldest U.S. presidents. So we had Trump, who was 70 when he became, Reagan 69, Harrison was 68, and Buchanan was 65. So these are when they were inaugurated. The four oldest presidents at the time. So 70 minus 65 is 5 years. So there's a range of 5 years between the oldest four. Now, what would be interesting is saying if we looked at all the presidents, I think you have to be 45 to become president. I don't remember. Kennedy, I think, is one of the younger presidents. I don't remember his age. Obama was actually fairly young for a president, but I don't remember his age either when he became president. But let's say, you have to be at least 45. So someone was 70. We don't have to mention the name. So that would be what, 35? That's a range of 35 years. Now, in this next one coming up, now if let's not even look at that. Let's see, how old is Joe Biden? I think he's like 78, 70. He's upper 70. So if he were elected, he will now take the record for being the oldest president at time of inauguration. Right? That's where this is important. Okay. Because Reagan was 69. Did he do 2 terms? I think he did 2 terms. So you add 8 years to that, and then he lived a few more years after that. That's pretty good. So what, he was like 70, 77 when he finished, and then he lived. I think he lived into his 90s. I wasn't much of a supporter when he was president, but after I look back on him, he did some good things. And that's what you look at. What did they do that was good? I don't agree with everything. Harrison and Buchanan, those were way before my time. Okay, so that's getting at the range. So now here's the standard deviation. I'm going to give you a link in Canvas for a statistics calculator. You can just, if you want, go online, just type in statistics calculator. You'll find several different ones. They're all free, where all you have to do is enter the data set. In fact, let me do it right now. While we're here, we'll do it live. This is a live thing, so it's always kind of nice to do it this way. Where are we? Let's go here. We've got things uploading. You can see that part. That's fine. Let's go here. We're just going to type in statistic calculator online. Why not? It's nice that they give you these suggestions. So here's the best one. I think I've used this one before. There's also this one, quick statistics calculator. There's a bunch of them in here. So if you don't particularly care for the one that I put the link for, and I think I'm going to use this one. It's because it says it's easy to use and it's free. Well, we'll see. Okay, so we click on this. So I always have all this. Okay, easy step. Click start now. Download it on our website. Get access to your email. I don't know. I don't want to do that. I want to remain anonymous. This one looks too complicated to me. It might be helpful when we want to do all these things, but we're not going to do this. I just want something easy where it says, give me the data and I'll calculate here we go, statistics calculator. So what we can do here, right, we could just like copy and paste our data in. So I'm gonna come here. Let's see how this works. So I'm going to see, will it let me, because I'm in here, but it won't let me copy it. So I can enter them. It's, let me make this a little bit smaller. So watch, we're gonna put in 70, comma, 69, comma, 68, comma, 65. Then we're going to calculate. What does it give? And look, it gives us everything. Your TI-84 calculators, if you have one, it will do the same thing. It gives you everything here. So we've already got our standard deviation, and we've got the sample standard deviation. Actually, this is a good thing because there's two types of standard deviation. When you're doing the sample standard deviation, that's for measurements under 30. It's a slightly different formula. And since we only have 4 pieces of data, this is the one we want to use. So we want to give it as 2.16. Okay, when we get to that. Well, I won't write it down, but we're going to see we can use this again. We've also got our mean, which is 68, and they've done it here, calculated the mean, add them together, divide by 4. There's our 68. But notice this calculator just did it for us, right? Got us our found our median for us as well. So maybe I should have done this first, but I wanted you to do some of the calculations by hand, but this will find the median for you as well. All the values appear once, high or low, it gives you everything, okay? So now I want you to just see how the standard deviation is calculated. When you go to the homework, I would prefer that you use the graphing or the calculator to actually calculate it, but I want you to understand where it's coming from. So for standard deviation, what we do is we calculate the deviation. So we take the data item, 70, and we subtract the mean. Notice each of these is subtracting off the mean. So what we are finding is how far from the mean is each piece of data. That's how spread out it is, right? Well, watch, if you add all these together, 2 plus 1 is 3, that's still 3, a negative, oh, we will always end up with 0 if we add all the deviations, which is not helpful. If you always get 0, then it's not a measurement that's going to help. So here's where the standard deviation has sort of been a manipulation to make it useful. Instead of just adding all of them, what we're going to do is we're going to do all of this. We are going to, so the first step has already been done. What we're going to do is we're going to square it, because when you square a number, it's always going to be positive. So let's go back here. 2 squared is going to become 4. 1 squared stays 1. 0 squared stays 0. Negative 3 squared is going to become 9. Now look, when we add all these numbers, so all we did is we I should write 2 squared, 1 squared, 0 squared, negative 3 squared. Okay, so we get these numbers. Now when we add these together, we're going to get 9, 10, we're going to get 14. What we're going to want is sort of like an average spread, because this is sort of the spread, but it's the spread squared. We'll come back to the thing. So then what I want is how many are there? There's 4. And this is where I've told you, so typically we would just divide by 4 to get sort of an average, but what we do is we do 4 plus 1. Okay, we add that extra 1 when we're dealing with a sample, a small number. Okay, and then in the very end, since we squared everything, right, this was a manipulation. What we're going to do is unmanipulate it. We're going to take the square root. Okay, and that's what we're going to call the standard deviation. Let's go back to the next page. So that's what, with this numbers, what we do is we calculate here, subtract the mean from each of them, square each of those deviations, add them together. We're sort of finding an average, but again, when we're under 30 pieces of data, we do a sample thing where it's n plus 1. Or is it n minus 1? No, it's n plus 1. I'm pretty sure. And then at the very end, we square root it to undo the effect we gave when we squared it. Okay. I am recording. Okay. So then again, and so then what we did was we add them all together. Remember, this sigma thing just means add them together. So we took our square numbers, added them. It's in -1. Okay. Let's back up a step. So forget everything I said. We're going to subtract 1 in -1. Okay. And that's why I said is I don't like to memorize data formulas so much, because whether you add or subtract 1 is a big difference, because this is going to be now divided by 3, right? So it's going to be 14 divided by 3, and then we'll take its square root when we're done, and that will be our standard deviation. Okay, but that's why I want you to use the calculator. With the calculator, you don't have to memorize any of these formulas. And this one is again, I want you to understand, though, when we're calculating this, it's sort of a manipulation. Where did this n minus 1 come by? Well, it's a manipulation. It just found out, well, if we're under 30 pieces of data, then we should do this and we get a better number. If we're over 30 pieces of data, the subtracting 1 doesn't make enough of a difference to matter. But when we are under, we subtract the 1. Okay? And so then they do that calculation, and then the standard deviation is you square root, which undoes the effect of squaring. Okay, so it's you know, here this is a very understandable, getting the deviation. That makes sense. We got something that wasn't helpful, so the rest of this is a mathematical manipulation in an attempt to get to a number that would be useful. And so we square it, find sort of the average deviation, sort of. You know, again, this n minus 1 is not quite right. It should just be dividing by n. But again, it's a manipulation, because the people who came up with this said, hey, we like this number better. It's more accurate. It's more helpful. And then we take the square root, and we get a number that sort of measures. And all we know is that the larger that number is, means that there is more spread. The smaller that number is, means less spread. And it's really not, I won't say only, but it's most helpful when comparing two sets of data, which one is more spread out than the other. As an absolute value that of knowing that a standard deviation of 2 means exactly this, that's not as helpful. We will use that when we get down the road a little bit, and we will concretely understand that. That's in our last section, which is on using the normal curve. Okay, but for right now, we get a number that kind of gives us a feeling for how spread things are out, how spread out things are. Okay, so the larger the number, the more spread. The smaller the number, the less spread. And it's for what we're going to use it for is going to be mostly for comparison. Okay, so now they're going to go through these steps, which we've kind of already done. I didn't finish off. We found the mean to be 68, which is actually right there, right? Harrison was the average president of the top 4 as far as age. And again, here we go. We square it, which is 2 times 2, which is 4. So there's our 14, right? So they add all those together. So what you're doing is you're taking each data value, subtracting the mean, and squaring it, and then you're adding all of those together. That's 5. 5 plus 9 is 14. So you see, you have to have this whole table really to calculate a standard deviation. And if you've got 25 items, don't do this. If you got 10 items, don't do this. If you got 5 items, don't do this. Use the calculator. It will do it all for you. However, this is to get you a feeling that what we're getting kind of an average spread of the data, spread from the mean. So here's the middle of the data. How spread out on either side are we with our particular data? Okay, so we did that. We got our 14. You take the number of data pieces, which was 4, subtract 1. Again, just a manipulation. 14 divided by 3 is 4.67. That's something they call the variance. Let's come back to so 4.67 is the variance. Watch this. Come back to here, variance, 3.5. sample variance because they're doing the sample. See, when you don't do a sample, you don't subtract. It's just n. It's not n minus 1. And that's only used when you have more than 30. Okay, so all the data we're going to be dealing with is less than 30. So for this course, we just remembered the n minus 1. So sample variance 4.666 or 4.67. If you were to round it, 4.67. Wow, it all works. The calculator gave it to us. Just remember, in this course, we're dealing always with sample standard deviation, sample variance. And then this one is going to, this does all the calculations in one fell swoop. Just put your data in here. You may, by using MyMathLab, if they give you the data as a list of with commas like this, you can actually just copy it, paste it in here. It'll do all the calculations for you. What I want you focusing on is not so much the technical details of the calculation. I want to show you that to you so you understand what's happening. But I want you to be able to take that data, get these figures, and then understand what those figures mean for making decisions, okay? And being able to use them in a meaningful way. Okay. But at the very end, we take the square root of that number, which comes up to be 2.16. That is actually, back here, the sample standard deviation, 2.16. Beautiful. We got it all right here. So this is the process that you use. You might just, again, I would encourage you to try it once, maybe with this data, and actually write it down, because it takes it from the brain to the eye, comes in, it sees it, your hand's writing. It's an activity. It will bring the concept clearer to your mind and heart, and you'll remember it better than you'll just use the calculator to do it. But you'll remember what you're getting is it's involving the mean, and it's how spread out from the mean we are. So what we could say at this point, remember we came up with a mean of 68, and on average a standard deviation is about 2.16. So if we add 2, we get about 70. If we subtract 2, we get 66. So here's our 68. So if we had perfect symmetry, here's one standard deviation. And again, I'm kind of rounding, but a standard deviation is both above and below. And we look at our data, that's pretty much what it looks like, right? We've got a 65-year-old and a 70-year-old over here, a 68 and a 69-year-old. So it gives us a picture of what our data might look like. We know the average and we know the data spread. Okay. And that's all we need to do. So I'll put that link to that calculator because I think that's a pretty good one. There's some other ones that we will use later that give the normal curve as well, but I want to use as simple as possible one for these, and that one is just put the data values in, hit calculate, and you are good to go. Let's come back here just because I like the view from my penthouse office. Where am I? I think anyone knows this? I think this looks like Manhattan. Is that the Empire State Building? I don't know. I've never been to New York. It might be Chicago. Is that the Sears Tower? Anyway, let me know. I think one of you comes from Chicago, don't you? Anyway, keep making the good progress. We've got 2 more sections, and those sections will look at the normal curve, and that's based on the mean that we've calculated, the middle being the mean, and using the standard deviation to kind of come up with a visual of a visual distribution. And if a distribution is what we consider to be normal, that doesn't mean there's some special things. We'll talk about all that, but then we use that a lot in measuring things, and so we can. That's what a lot of statistics does, is how does it compare to the normal curve. So we'll get you through that, and then we'll be ready to study up and take our next test on statistics and probability together. I'll have some reviews ready for you as well. But keep in touch. If you have questions, let me know. But keep up the good progress. Thanks.